All right, so this recording is going to talk through the review of applications of derivatives, number one, and then hopefully by the end we're feeling pretty good. All right, so let's get rolling. So question number one, find the absolute extrema. Remember to find absolute extrema. We need to find critical values and endpoints. So my first step is I'm going to find y prime. So my first step is y prime, and the derivative of that thing, I'm not going to talk through it too much. I think we can all do derivatives at this point. So I have x squared minus x minus 2. Set that thing equal to 0. I'm going to go ahead and factor it at the same point in time. X squared gives me x and x. A negative 2, my only options are negative 2 and 1, or a positive 2 and negative 1. And I'm going to take the negative 2, positive 1, in order to get a negative 1 in the middle. Okay? My two values for x, that make that 0, R2, and negative 1. Okay, so now I need to show all my values. So I'm going to start at the endpoint, f of negative 2, and work it out. Then I'm going to find f of negative 1. I don't know why. I just like going in order. It doesn't matter at all. What's my next one? 2. And finally, f of 3. And again, it doesn't matter at all what you do, what order you put them in, but you need to show all 4. If you don't show all 4, it is not proven. It's not, you can't be confident that you found the absolute extrema because you're missing one. Okay, or 2, or however many you don't show. So you have to show all 4 key points. So you have 2 critical values and you have 2 endpoints. You must show all 4. All right, what I did is I just saved this function into my calculator as f of x, and I evaluated f of negative 2, f of negative 1, and so on, and work it out. And so when we do that, I'm going to assume you can do that on the calculator. If we did it by hand, should you be expected to be able to handle those fractions? Yeah, it just kind of depends on how big the test is. There's other things I want to check to see if we can handle besides can we handle fractions. So I probably wouldn't have one this messy on a no calculator part. So when I plug those into the calculator, that's what I got. And my largest, obviously, is my max, and my smallest is my min. And you can see my answers on the answer key, how I wrote that out. So this is my absolute max, and this is my absolute min. All right, number 2. Find the value of x that satisfies the mean value theorem. Mean value theorem, average rate of change, f of 5 minus f of 2, all over 5 minus 2, equals the instantaneous rate of change, f prime, somewhere in my interval. And that's what I have to find, is that c value. So my first step is, what is f of 5? So f of 5, if we plug in 5 here, we get 25. Plug in 5 here, we get 15. 25 minus 15 is 10, plus 4 is 14. So f of 5 is 14. Plug in 2. 2 squared is 4. 4, plug in 2 here, and I get 6. 4 minus 6 is a negative 2. Plus 4 is a positive 2. And then 5 minus 2 is on bottom, which is 3. So on the top, we get 12. Bottom, we get 3. And so we get 4 equals. All right, derivative, pretty easy. 2x minus 3. Not going to do anything else. Jump down here, 2x minus 3. Add 3, divide by 2, and x equals 3.5, or 7 divided by 2. Double check, is 3.5 in my interval from 2 to 5? And yep, it is. So we're good. Mean value theorem, average rate of change equals the instantaneous rate of change somewhere in the interval c, and that's my goal, is to find the c. Now I should have over here said something about mean value theorems if statements, and so I would say f of x is continuous and mean value theorem. That's it. F of x is continuous. Sorry, that's not it. F of x is continuous on the closed interval and differentiable on the open interval. Wow, I forgot my if statements. I knew that wasn't right. So f of x is continuous, and f of x continuous on 2, 5. Sorry, too early in the morning. At least I caught it before I moved on. F of x is continuous and is differentiable on the open, 2 to 5. All right, now we're good. And then I would go through the process of what I just did on the left. Okay, number 3. Where does a graph of the function whose second derivative is given by that have a point of inflection? Is this a trick question? No, but it is kind of just seeing, do we totally know the definition of a point of inflection? So I want to know, where is this second derivative equal to 0? But I also want to know, where does it switch signs? So I know it's going to be 0 at x equals 2. I know it's going to be 0 at x equals -3. Those may or may not be points of inflection. They are critical values, but they may or may not be points of inflection. So I want to check my values, and I don't have to do a number line, but a number line just kind of helps me stay organized. Nope, I don't want to do that. I want to go -3 first. And I'm going to check values to the left and check values to the right. So I have -3 and I have 2. So values to the left of -3, like -7. -7 makes this negative. This is always positive. So they're negative over here. Something bigger than -3 and between -3 and 2, like 0. 0 makes that positive. This is always positive. So that's positive. Greater than 2, like 5. That's positive. That's always positive. And so my only point of inflection is at x equals -3. Why? Because that is the only critical value where it switches signs from positive, negative, or negative to positive. Now, for this question, you did not have to show all that work. I simply showed all that work to show you, because this is a review, and I want you to see my thought process. I can see from this factor being squared that this will not be a point of inflection. The only point of inflection is here. Okay, I don't have to go through this whole process. I can see that if my factor is squared, the term, the 0 that gives me, or that I get from that factor, will not be a point of inflection. Just like it would not be a max or min. It would be a plateau point if my first derivative had that same property. Okay, number 4. Particle moves from right to left along the parabolic curve given there. Why are we moving right to left? Can we picture what this thing looks like? I should have gone further over, but that's all right. Normally my square root function goes this way, but since the x is negative, inside it goes this way. Now x's can't be positive, because now a negative positive number would make it a negative number, and that can't happen. X has to be negative, so the double negative makes it positive, and I can square root those. Okay, so that's why your particle is moving from right to left. In such a way that its x coordinate decreases at the rate of 8 meters per second. Okay, how fast is the angle of inclination of the line joining the particle to the origin changing when x equals -4? So way down here, when x is -4, angle of inclination from the origin to the particle. So this dude right here, we're going to call theta. So let's write down what we know. Particle is traveling at a rate, so dx dt is equal to -8. I am looking for d theta dt, and I want to write an equation that relates thetas and x's. Okay, so this guy right here is my y value. This right here is my x value, and this right here is my theta. I'm not going to try to write a theta in there. All right, so looking at those, I know that my trig function that deals with opposite and adjacent is tangent. So tangent is equal to y over x, opposite over adjacent. I want to write this in terms of variables that I know. I know something about x. I don't know anything about y. So I'm going to take the y out and put what y is in terms of x in its place. So I'm going to replace the y with what it is, which is a negative square root of negative x. And now I have my new equation. So let's take the derivative of that thing. Well, I'm going to do a little rearranging first. Make this a little easier to find my derivative. This guy up on top is, I really can't do that. Never mind. I was going to rearrange that to a 1/2 exponent, but my insides are different, so I'm going to leave it. All right. Derivative tangent. Secant squared. Quotient rule. Derivative of the top. Times the bottom. Oops, forgot one more thing. Right, so this is x to the 1/2. So the 1/2 comes in front, decrease the 1/2 by 1, leave the inside function alone. Multiply by the derivative of my inside function, which gives me a negative 1. Okay, derivative to the top times the bottom minus the top times the derivative of the bottom. Whoops, get kind of caught. Hang on. For some reason it glitched. Okay. Sorry. Maybe I can undo. There we go. All right. For some reason my pen locked and it froze on that. All right, so start over here. Uh-oh. The spinny wheel of death. Is it going to recover? Okay. One more time. Derivative of the top times the bottom minus the top times the derivative of the bottom, which is 1, all over the bottom squared. At this point in time, oh, I missed something. Wow. I missed a whole lot of something. I forgot my dx dt's and my d theta dt's. I hope you were yelling at the camera or yelling at the screen. That should have a d theta dt on it. And this right here, derivative to the top, should have a d theta dt or dx dt sitting right there. Sorry. And my times by 1 should be times by 1 dx dt right here also. All over the bottom squared. All right. I think I'm okay. Sorry. Okay, now plug in what I know, and let's simplify this thing. So let's look back at my picture. I'm going to draw a little bigger triangle. So there's my triangle. The moment when x equals a -4, so this is a -4 right here, and if y equals the square root of a negative x and y is the square root of 4, which is 2, and if Pythagorean theorem holds true, then this should be the square root of 20. And if this is my theta, secant is 1 over cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And if I square that, then I get the square root of 20 squared, which is 20, over 4, -4 squared, which is 16. And d theta dt is what I want. So I'm going to leave that in there. Okay. Right-hand side. I get 1/2. Plug in a -4 here. Becomes a +4. 1 over the square root of 4 is 1 over 2. So 1/2 times 1/2 is 1/4. Plug in a -4 here, and I get a -4 times a -1 is a +4. dx dt we said was a negative 8, and so this becomes a negative 32. Negative 1 times a negative 4 is a positive 4 times a negative 8 is a negative 32. Looking at my answer key, I show I have a positive 32 down there. I forgot the negative 1 on my derivative. Man, make mistakes all over the place. All right, at least I caught it on this thing. All right, plug in negative 4. Negative 4 is positive 4. Square root of 4 is 2. 2 times a negative 8 is a negative 16. Minus makes that a plus, and I get a positive 16 here. All over negative 4 squared, which is 16. Solving for d theta dt. I'm going to multiply by the reciprocal of this thing, which is going to put the 20 on the bottom. And this 16 and this 16 will cancel, and I'll have a 20 on the bottom, and this is going to be gone. 1/4 times a negative 32 is a negative 8, plus 16 is a positive 8. And 8 divided by 20 that's an 8. 4/5. So ignore my answer key, unless I just did, how about I do it right? It's 2/5. Ignore my answer key unless I just did this one wrong. Then ignore what I just said and look at my answer key. Because at this point in time, I've made so many mistakes, I don't know which one's right. No, I do know which one's right, but I need to have to go back through and double check both of them. But I think we're good right here. So x equals, or d theta dt equals 2/5 instead of 6/5. And my units would be radians per second. All right. Question number 5. So the graph of f prime is shown. Which of the following statements is true? So let's go through them all. A, f is decreasing. F is decreasing implies or states that the derivative would be negative. Is my derivative negative from a negative 1 to 1? No, my derivative is positive here and negative here. So my derivative is not negative for that whole entire region. So A is gone. C, it's increasing from 1 to 2, which means my derivative is positive from 1 to 2. My derivative is not positive from 1 to 2. Why? Because it's below the x-axis. Remember, I'm looking at actual values of my derivative. Okay, these values are all negative from here to here. Okay, f is not differentiable at negative 1 and 1. F prime is not differentiable, but since there's a value right here and right here, it is differentiable. There's a value for it. Okay, there is no second derivative. F prime is not differentiable because it's a cusp or a corner there. But f is differentiable. And how do I know? Because there's a value there for the derivative. There's not a hole there or a jump or a break in the graph. Question B. F is increasing from a negative 2 to 0. F is increasing, which means my derivative is positive from negative 2 to 0. Correct. This one looks right. Let's just double check. F has a local min at 0. F is increasing on this side because my derivative is positive. F is decreasing on this side. It's not a min, it's a max. Answer B is correct. All right. This is my graph of F. So when you read the question, be careful to identify, is my graph F? Is it F prime? Is it F double prime? Super important. Obviously, they mean way different things. Okay, so this is a graph of F. What I noticed right away is F is always increasing. Since F is always increasing, F prime is always going to be greater than 0 because it's always increasing. I also notice that this graph is strictly concave down. So my second derivative is always negative. When I look at the value at -1, it is equal to 0. So when I'm comparing these, f double prime of -1 is less than 0, f prime of -1 is greater than 0, and f of -1 is equal to 0. Now let's rate them in order, from least to greatest. Obviously, this is the smallest because it's less than 0. This one equals 0, so it's next. And this one is greater than 0, so it's the greatest. So what's my answer? So f double prime is smallest, and then f, and then f prime. Looks like B is my answer. All right. Sorry, I had to cough again. All right. Super important that we can compare f, f prime, and f double prime. Question 7. Here's my function. The graph is concave up when? Concavity, second derivative. So let's just cruise through and find all of our different derivatives. So f prime is equal to 3x squared minus 12x. F double prime is equal to 6x minus 12. Solving that thing, set it equal to 0, I get 12 equals 6x. X must equal 2. So concave up, I want to know where it's positive. So you don't have to number line it, but I'm going to check numbers to the left, like 0. Where do I plug in the 0? First derivative, second derivative, or original function? Concavity says my second derivative must be positive in order to be concave up, and second derivative must be negative to be concave down. So I want to plug in 0 or these values into my second derivative. 6 times 0 is 0, minus 12 is negative. Plug in like 3. I get 18 minus 12 is positive. Concave up, concave down. What's my answer? Looks like my answer is A. Question 8. We have an equation for y. We have a dx dt, and we want to find dy dt. Another way of saying find the derivative at x equals -2. No, sorry. Find the derivative of y when the derivative of x is equal to -2. And x equals -3. Sorry. And we're doing this in terms of t. Okay, how do I know? Because it tells me right here. So all of this is going to be an implicit differentiation. Y prime, or derivative of y with respect to t is dy dt. Derivative of x cubed is 3x squared. And I'm not taking the derivative with respect to x. I am taking it with respect to t. So I have to have that in there. Derivative of a -4x is a -4. And again, I got to have my dx dt. Plug in the information. -3 squared is 9 times 3 is 27. Negative. Dx dt is a -2. That's not an equal sign. I have a -4 times a -2. And so I get 54 plus 8. Is that a negative? That's positive. Oh, that's positive 27. Sorry. You probably caught me. That's a -54 plus 8 is a -46. -3 squared, +9, +27. Yeah. All right. Question 9. Rectangle has a base on the x-axis. Its upper vertices are on the parabola given. What is the largest area? Wow. Not a good start. Let's try to make a straight line. There we go. So this parabola starts as a y-axis of 12. That's my vertex also. And it hits the x-axis somewhere down here. So this parabola here has its base on the x-axis and the other vertices on the parabola. So I have some rectangle inscribed inside this parabola. So this distance from here to here is x. This is a negative x, but as far as distance, it's just x. And this distance up here is y. What is the largest area? So remember, I'm writing the equation that I'm trying to minimize or maximize. And the area equation is length times width. My length is not 1x like I just wrote. My length is 2x. And my height is y. Now, I don't want my equation in terms of both x and y. I want it in terms of just one variable. I know my y, so let's just plug in what y equals in terms of x. And I'm going to rewrite that a little bit. I get 24x minus 2x cubed. And I'm still looking at a. Have not taken the derivative yet. Okay. All right. Next step. Let's take the derivative. So we get a prime equals 24 minus 6x squared. Set that thing equal to 0 to find my critical values. I'm going to factor out a 6. A 6. Why did I write 4? Factor out a 6. And I get 4 minus x squared. So my x values are plus or minus 2. Now, since we're talking about distance, if I look at this, x could be a positive 2 or x could be a negative 2, which makes my bottom of the rectangle, the base, 4. So this is going to be 4. What do they want? What is the largest area? So the area is going to equal 2 times 2, which is 4. Now I'm going to plug the 2 in up here. 2 squared is 4. 12 minus 4 is 8. And so this right here is going to be 8 times 4. So my largest area is 32, and my dimensions are a length of 4 and a width of 8. And it doesn't matter. You could switch the names. It could be a width of 4 and a length of 8. It doesn't matter. Okay, and my units are what? I don't have units. So it should be 4 units, 8 units, and 32 units squared. Okay. All right. Question 10. Find all critical values for that function. That's pretty straightforward. Derivative. Y prime. Bring the 1/2 down in front. Decrease the exponent. Whoops. Decrease the exponent by 1. Multiply by the derivative of the inside function. And set that thing equal to 0. Man, I look at my answer key. I don't have the negative sign there. So 0 equals on top. This is going to go on, I won't skip any steps. We have a negative 2x on top. We have a 2 times the square root of 1 minus x squared on the bottom. Where's this thing equal to 0? Well, where the top is 0, it's equal to 0. So one answer is x equals 0. And where the bottom is equal to 0 is where it's undefined. And so we have another answer at plus or minus 1. Okay. And yeah, these things cancel and I get a negative x there. Fortunately, it doesn't change my answer because the negative 0, positive 0 doesn't change. Okay. Can we all see that this is 0 at plus or minus 1? Hopefully we can. If not, you would set that equal to 0. 2 equals the square root of 1 minus x squared. Why did I say 2 equals? 0 equals and there's a 2 here. Divide by 2, and I get 0 equals the square root of that. Square both sides, and I get 1 minus x squared equals 1, or equals 0, then 1, equals x squared, square root, and I get plus or minus 1. But hopefully we can see it right here. AP test, efficiency is pretty important. So it's important to see it right here, not have to go through all that mess. Okay? All right. Last couple. Oh, I didn't get them copied over. Give me 1 second. Maybe I can get them copied quickly here. Yeah, I didn't get a whole bunch copied over. All right. I'll make a new video, get those copied over, and I'll have a part 2 to my recording. All right. So for now, stay tuned for part 2.